Hi, my name is Chris, and welcome to our short physics video series. Today, I'll be going over how a better understanding of free body diagrams can help you better answer the questions here in our 2020 HSC past paper. Let's dive in. A free body diagram is a sketch of an object of interest without its surroundings, and it only shows all the forces acting on the body. It helps us visualize all the forces to determine what is the actual net force acting on our object, so that we can apply Newton's second law of motion. Feel free to pause the video and attempt the question yourself first. But now, diving straight in, our electron, in order to make this type of trajectory, would require a force acting straight down. And this would mean that our bottom plate is positive, our upper plate is negative. And looking at our question, this will tell us that electric field must be going up the page, which eliminates C and D. For our second electron to pass through the field undeflected, we need an equal and opposite force acting up the page to get zero net force. Now, using our right-hand rule, we will be able to determine that the magnetic field should be going out of the page, right? Out of the page, which means that B is only our correct answer. Now, do note when using your right-hand rule, make sure to flip our thumb 180 degrees to account for the fact that it's electron flow that we're considering. So moving on to the next question, we have a rocket with a mass of 7,800 kilograms traveling at 20 meters per second across, and its engine thrust is 90,000 newtons. So the object of interest is our rocket. And now for any object that's close to Earth, it's going to have a gravitational force. Now we know that the thrust is going to be up the page. So we must first determine what are the sizes of both. And thankfully, we got the thrust given. Fg is going to be determined by mg, m being 7,800 and g being 9.8. We get a result of 76,440 newtons. So this tells us our net force is going to be up the page, giving us an acceleration by Newton's second law, also in that same direction. And if we have acceleration, and there is an initial velocity horizontally, well, this should remind you of a particular type of motion being projectile motion. But unlike the typical ones we see, this one is upside down. Now onto the final question. Here we have a ball that follows the trajectory around the wall before landing on the ground. And initially, you have to note that it has a velocity u, right? North at an angle that's horizontal. That's at an angle to the horizontal. So in this case, there is kind of two motions that are combined. First, we have projectile motion, but now we also have centripetal motion. that's guided by this vertical wall. So again, breaking things down to our object of interest, it is definitely this ball. We have two types of forces acting on the ball. First, we have gravitational force acting vertically down the page. Second, we have a contact force that is acting always perpendicular to the surface of the wall. In this case, this contact force, or let's call it the normal force, is constantly changing directions based on the surface of our vertical wall, except relative to our FG, no matter where the ball is, it is going to be 90 degrees to our gravitational force. Meaning, if we resolve those two forces, you will always have what? You will always have a constant sized resolution force, or net force rather. So this points our answer to A. I hope you've enjoyed this video, and we'll see you in the next one.